Welcome back to Algebra with Miss Swartz. Today we're going to look at our vertex form. So yesterday we kind of looked at absolute value graphs and just kind of what they look like and graphing them with XY charts and kind of how that impacted our parent function of our graph of x equals the absolute value of x. And we are able to see some correlations between when something was happening inside the absolute value and when something was happening outside the absolute value, and when we were working in front of the absolute value when we were multiplying. So we saw some of those pieces just by using the XY charts. Today we're going to focus in, so now maybe we don't want to make an XY chart every single time we have to graph an absolute value function. So what can I learn and what form can I look at, kind of like y equals mx plus b, where I know this is my slope and this is my y-intercept, which makes it pretty easy to graph. I graph on my y-intercept and then I can count my slope up 2/1 and I can get a point and I have a line there. What can I do with vertex form that's going to help me graph my absolute value function? So let's go ahead and take a look. So this is probably the most important piece, and I would like you to write this down. It says the vertex form of an absolute value function is written in the form g of x, remember that's like y, equals a times the absolute value of x minus h. Notice that this is a minus, and then plus k, where a cannot equal 0. That's vertex form. The vertex of the graph is at hk. Okay, so it's at hk there. So that's going to help us graph a lot because now we know exactly where the vertex is. So it says any absolute value function can be written in the vertex form and its graph is symmetric about the line x equals h. So if you notice here, your x value of your vertex, that's where it's going to be symmetric around. So both sides are going to look the same from there. So my notes here kind of give you what you need to know. H, so inside the absolute value, is going to move the graph horizontally. And we saw that yesterday. The parent function looked like this. And when we had a graph that was f of x equals the absolute value of x minus 2, it actually moved our graph over 2 to the right, and it looked like that. K is going to move the graph vertically. When we did that, we had the last one that we did was f of x equals the absolute value of x minus 3, and our vertex was down here, and it looked like that. And then what we need to know for now about A. We aren't actually going to have numbers within A right now. All we're going to see is sometimes A is going to be negative, which we looked at yesterday as well. When A is negative, it's going to flip our graph upside down. It's reflected. So we had, I think what we did was negative 1/4. Okay, we won't actually have this. All of our A's will actually be 1 today or negative 1, but if it's negative, that's when we know it's going to flip upside down. So this kind of gives us an idea, since we know that our vertex is going to be at hk, and we know that A is going to tell us if it's heading up or heading down, we can kind of work on our graph from there. So today all we're going to do is graph about 6 graphs together, and then that'll kind of be your notes, and then you'll have a worksheet over this information. Okay, so we're just going to try to graph these together. So we'll do 2 at a time. We're going to do number 1, we'll do this one here down on this graph on the left, and this one down on the graph on the right, and then we'll erase and do number 2, and then 3, so on and so forth. Okay, so yesterday with this we made an XY chart. Today what we're going to do is we're going to look at it in terms of our vertex form, where we're thinking about it like this. So we know that with this, our vertex is going to be at hk. Okay, but we want the subtraction sign there. If it is a positive sign, we're going to treat h like the opposite, which is kind of hard to think about because normally we would think the other way around. But in this case, when we're inside the absolute value, we have to think about that negative kind of like a positive. And then k is going to be like normal. We want plus k out there. So if we look at this graph to start, my vertex is going to be at, well, h is here, and there's a subtraction sign, so I'm going to leave it as positive, 1, comma, and then there's nothing on the outside being added to it. So if there's nothing being added to it, I'm adding 0, so 1, 0. My k is 0. So I know my vertex is going to be at 1, 0. It moved it horizontally 1 space. Okay, from there, I can tell by A if my graph is going to be going up or if it's going to be going down. Well, it's positive, so it's going to be going up. And because A is not a number, it's not affecting our slope at all. So these are just going to go up by 1 each time. So at 2, it's going to be at 1. At 0, it's going to be at 1. And you can check that. So 0 minus 1 is negative 1. The absolute value of negative 1 is 1. 2 minus 1 is 1. The absolute value of 1 is 1. So you can go out to 3. You can go up by 1. So each time you're going up over 1, up 1. Our slope is 1 over 1. So this would be our graph right there for number 1. Now, if we look at this graph, it's going to look just slightly different. If we think about here in our vertex is actually going to be the same for this graph. It's going to be 1, 0 because h is 1 and k is 0. So we're still going to be right here. But in this case, since we have this negative here, it's going to be heading down. So at 0, it's going to be at negative 1. At 2, it's going to be at negative 1. At negative 1, it's going to be at negative 2. At 3, it's going to be at negative 2. Okay, you can kind of check those. So 2 minus 1 is 1. And then we have the absolute value of 1 is 1, but then we're taking negative 1. So now we know that that is good. Here is our graph for this one. So every time you're looking at these graphs, your goal is to figure out your vertex. From your vertex, since we're not going to have A affecting our slope at all, we can just graph our vertex, and our slope is 1 over 1. So each time you go up 1, you go over 1. Or each time you go over 1, you go up 1. Either way. So we're going to erase these two graphs. You should have wrote those down. If you haven't, you can pause it and grab a graph sheet of paper and write them down. And then we're going to go ahead and look at number 2. Okay, so if we look at number 2 in this vertex form, and we're thinking about it in vertex form, we have to decide what the vertex is here. So there's nothing happening inside the absolute value. So we're going to call that 0 because there's no h. Nothing's being subtracted. So our h is 0, or our x value of our vertex is 0. Our k is 3. So our vertex is going to be at 0, 3. So notice it was outside, or our k's are going to move it vertically. And that's something you can remember. So 0, 3 is here. Since our a is positive, we're going to be heading up. So if I go over 1, I'm going to go up 1, over 1, up 1. Remember, it's symmetrical along your h there. It's going to look the same on both sides, and there we go. So that would be our graph for g of x equals the absolute value of x plus 3. And you can test those out. So 1, if I plug 1 in there, the absolute value of 1 is 1. 1 plus 3 is 4. The absolute value of negative 1 is 1. 1 plus 3 is 4. So let's look at this one. Now it's the same thing but with a negative. So our vertex is still going to be, our h is still 0, our k is still 3. But this time, we have a negative out in front, so now we're heading down. And again, check them if you need to. Okay, so at negative 1, the absolute value of negative 1 is 1, but I have a negative there, so a negative 1 plus 3 is 2. And that's where we're at. So my graph would look like that. All right, so then we have 2 more examples left here. So for the first time, now we have 2 operations happening. So again, for number 3, this first thing we want to do is figure out our vertex. Okay, so inside here we have h, and we want to determine what h is. Well, it looks like h is 2, but notice you have a plus symbol here. Since you have that plus symbol, we actually have a negative 2 in there. It's the opposite inside of the absolute value. And then we have a plus 2. Well, since it's plus 2, that's exactly what our form says, so we're going to have 2 there. So our vertex should be at negative 2, 2, based on the fact that HK is our vertex. This moves it horizontally, this moves it vertically. So I'm going to go to the left 2, up 2. This is my vertex. Now, the A is positive, so I'm going to be heading up, and A is 1, so I'm just going up by 1. So over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. Okay, so my graph should look like that. Okay, so check it if you need to. So negative 1 plus 2 is 3. 3 excuse me, so negative 1 plus 2 is 1. The absolute value of 1 is 1 plus 2 is 3. So there we're in the right spot. Same thing with negative 3. That would be negative 1. The absolute value of negative 1 is 1 plus 2 is 3. All right, so then we're moving over to this one here. So if we look at our vertex again, since it's a plus, this is going to be a negative 2, and then out here it's 2, so it doesn't change. The only difference here, negative 2, 2, is that it's going to be heading down because we have a negative. So over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1. This would be our graph, and you could check that if you would like. There we go. Okay, so on your homework, you just need to figure out the vertex. That's your biggest piece. Figure out your HK. Go from there and graph it. Your slope is always going to be your 1. Okay, it just depends on if it's going up or down based on the negative. If you have questions, don't hesitate to come see me. Once you're done, I want to kind of look at your notes, make sure you wrote it all down, and I'll get you your worksheet. Have a great day.